everyone. So in our last video, we saw that we could combine together functions using operations like addition, subtraction, multiplication, and division. And so in this video, we're going to be seeing a new and pretty different way of putting two functions together. So let me just kind of summarize that. In the last video, we saw that functions can be through addition, subtraction, multiplication, and division. So for example, if you wanted to do f plus g of x, make a new function where you're adding them together, well, you can do that by taking the formula for f of x and adding it to the formula for g of x. And so in all of those different ways of combining functions, really we were just dealing with the outputs of the function, right? Like we were leaving the inputs as just x, and then just taking those formulas, the formulas that you use to calculate outputs, and just adding them together, subtracting them, multiplying them, and dividing them. And so in this video, what we're going to be doing is fundamentally different, because rather than just taking these formulas for calculating outputs and just kind of putting them together, instead we're going to be taking one function's output and plugging it into the other function so that the output of one function becomes the input of the other. So in this video, we will combine functions through a method called composition. And I'll get a little bit more specific about what that looks like in a second, but again, just to kind of briefly summarize it in words, basically when you compose two functions, the output of one function becomes the input for the other. And another way of thinking about it is basically that you're going to be kind of plugging one function into another function. So that might sound kind of complicated. I think once we get into some examples, it will become a lot clearer how this works. Okay, so just like what we did in the last video, this is going to be not so much a table, but I still want to write this down in the same format as we did in the last video, just to kind of connect it. So just like when we combined functions using addition, subtraction, multiplication, and division, we had this like name for the function, right? So like here, we could call the function f plus g of x, and then this is how you actually go about coming up with the formula. Similarly here, when you're composing two functions together, we're going to use a new symbol, which is this little circle. It's kind of like the degree symbol, but like in the middle rather than up high. So it's not the letter O, it's just like a little circle. And so when you write this down, f composed with g of x, how do you actually go about kind of turning that into a formula for a function? Well, what you're going to do is you're going to take the function g of x and plug it into f of x. So the output of g of x is going to become the input for f of x. And then if you do it the other way, so if we have g on the outside and f on the inside, so whichever function basically is closer to x is the one that's going to end up on the inside, well, then you're going to be taking the function f of x and plugging it in to g of x. So by the way, how do you read this out loud? You could read it. So personally, I tend to actually, I said that this is not an O, and it's not, but I tend to kind of think of it as like a little O that stands for of. So you could read this out loud as f of g of x. And you could read this out loud as g of f of x. g of f of, sorry, x. So that might help you remember how to like translate it into this, is that, whichever function comes first, that's one that's going to be on the outside, right? Because it's going to be f of g of x. Okay, so let's get into some examples of this. So let's say that we have two functions. One function is going to be x squared, and the other function is going to be x minus 3. So we're going to find f of g of x and g of f of x. So I'm going to actually, let me first write it down like this. And so I'm going to do a little bit of color coding just so that we can really visualize what's happening here. So I'm going to take the outer function and I'm going to color code it so that the input has a certain color, kind of like I did on our like intro video talking about functions. And then I'm going to label g of x with that same color. Okay, so how do we actually do this? Well, we know that f composed with g of x. That means we're going to take g and plug it into f of x, right? That's like literally, as soon as you see this, you want to rewrite it like that. Always. I would say the students tend to make a lot of mistakes on this. They kind of do it backwards, and 9 times out of 10, if a student is making a mistake on it, they're not writing down this step. So make sure you first kind of translate it into this format. And I'm actually going to color code this part as well. Okay, so once we have it written like this, f of g of x, what we can do is we can, instead of writing g of x in these parentheses, I'm just going to replace it with what g of x actually is. So what is the formula for g of x? How do you calculate outputs for g of x? Well, you use the formula x minus 3. So now how do we go and evaluate this? Well, now this goes back to the first week of class, right? In the first week of class, we were talking about evaluating functions at expressions, and that's exactly what we're doing now. So all we're doing, you can now forget about g of x, forget this ever existed, focus in on this. How do we evaluate f of x minus 3? Well, we just replace x with x minus 3 in the formula. So if the function f of x is equal to x squared, that means that f of x minus 3 is going to be x minus 3 squared. So we can now say that f composed with g of x, our new composed function, is going to be equal to x minus 3 squared. So one thing you can kind of see here is that the function that was listed first, so the function that was on the outside, well, that ended up being kind of on the outside of this function, right? The square ended up being on the outside, whereas the function that was on the inside, so that was g, well, that ended up being on the inside, right? X minus 3 is on the inside of this function, whereas the square is on the outside. So let's do it the other way. So now we're going to do g composed with f. So again, I'm going to color code this so that it can help us kind of make the connection that I want to make here. So the function g of x was equal to x minus 3, right? So I'm just color coding this to remind you that whatever ends up in those parentheses, that's what you're supposed to replace x with. And so the function f of x, as we saw, was equal to x squared. Okay, so how are we supposed to do g composed with f of x? Well, it's supposed to be g is on the outside and f of x is on the inside. And so now we can just replace f of x with whatever f of x is, and in this case, f of x is x squared. So instead of writing f of x in these parentheses, I'm just going to write x squared. And then the last step is just to actually evaluate the function. So again, at this step, you can forget about this, you can forget about this, just focus on this. Just focus on evaluating g of x squared and pretend that it's the first week of class. And so how do you evaluate g of x squared? Well, you go back to your function g of x, and g of x tells you to take your input, and so in this case, our input is x squared, and then subtract 3 from it. So we're just replacing we're replacing x with whatever is in our parentheses, which in this case is x squared. And so our new composed function that we came up with is g composed with f of x is equal to x squared minus 3. So just like we did in the last video, notice we're building these new functions. So these are functions just like any other. It's just that the process for building them up is a little different than the last video. It's not just adding or subtracting, it's kind of combining them in this more intricate way. And again, I would look at how do these functions differ from each other, right? So we talked about how for this example, the square ended up on the outside, and that's because f of x, the squaring function, was the one on the outside, whereas x minus 3 ended up on the inside, and that's because g of x was the inside function. Whereas on this function, well, in this function, the minus 3 is actually on the outside, right? And so why is minus 3 on the outside? Well, because the function that subtracts 3 is g of x, and that was the outside function. Whereas the x squared, well, that's the thing that's kind of getting subtracted from. That's like on the inside more so. And so that's because f of x was our inside function, and that's the function that takes things and squares them. And so that's why that ended up, on the inner part of the function. Okay, so let's do a couple more examples. So this time, let's say that f of x is equal to 2x plus 1, and g of x is equal to 1 over x. Okay, so I'm going to drop the color coding this time. So we're going to try to find f composed with g of x and then g composed with f of x. Okay, so what's our first step for finding f of g of x? Well, we want to rewrite it as f of g of x. So now what do we do? Well, instead of writing g of x in these parentheses, we can replace g of x with what g of x actually is, right? G of x is 1 over x. That's the formula for g of x. And so what is our last step? Well, now again, forget about all the composition, just think back to the first week of class, and we're just trying to evaluate this function, and instead of plugging in a number, we're plugging in 1 of x. So we want to replace every occurrence of x with 1 over x. And so what is that going to look like in this case? It's going to be 2 times 1 over x plus 1. And so that simplifies to 2 over x, right? Because 2 times 1 over x would give you 2 over x plus 1. And so that is our new composed function, f of g of x. So I know I said this a few minutes ago, but I'm just going to say it again. People tend to kind of get these backwards. So oftentimes a student will, instead of writing down the correct answer for f of g of x, they'll write down the answer of g of f of x. And when that happens, it's usually because you're not doing all these steps. It's because you're trying to kind of just combine them in your head the first way that you think of. And so really to get these correct, and to really understand what is the inner and outer function, I really, really think you should write down all of these steps. So write it down as this kind of formula notation like this, then replace your inner function with whatever the inner function actually is, and then you're just at that kind of problem like from week 1 where you're just plugging an expression into a function. Okay, let's now do the other way. So let's do g of f of x. So now we're going to have the function g on the outside, and we're going to be plugging f of x into g of x. So next step would be to, instead of writing f of x in our inside, let's write down the formula for f of x. So what is f of x? F of x is 2x minus 1. Okay, so now again, we're at that step where we just need to focus on what is our function and what are we trying to plug into that function. So our function g of x, whatever our input is, we're supposed to do 1 over that input. So if it was 5, it would be 1 over 5, right? G of 5 is 1 over 5. So if we're plugging in 2x minus 1, well, that means we need to do 1 over 2x minus 1. So we're just replacing our input with 2x minus 1. And so that tells us that our new composed function is g composed with f of x is equal to 1 over 2x minus 1. So let's do another example. And if you haven't already, I would recommend pausing it and trying this next example yourself. So in this example, let's say that our function f of x is equal to the square root of 3x, and our function g of x is equal to x plus 5. So we're going to do both, right? F composed with g of x and g composed with f of x. Okay, so let's start with f of g of x. So we're going to put f on the outside, g is going to get plugged in. And so we're going to end up with f of x plus 5, right? Just replacing g of x with the formula for g of x. And so what does the function f do? Well, we're supposed to take our input, multiply it by 3, and take the square root. So what do we have to do in this case? Well, we have to do that with x plus 5, right? X plus 5 is what we're going to be putting in for our input. And so what is that going to look like? Well, it's going to be the square root of 3 times x plus 5. So I'm just replacing x with x plus 5 because that is our input. And so we can simplify that a little bit and say at the end of the day, our formula for f composed with g of x is the square root of 3x plus 15. And then the formula for g of x, or sorry, for g composed with f of x. So this time g is on the outside and f is on the inside. So first step again is to replace f of x with the actual formula for f of x. So that's the square root of 3x. And then we just need to evaluate our function g of x. So now this time we're plugging into this function, and our input is the square root of 3x. And so we're going to end up with the square root of 3x plus 5. So we're just replacing x with the square root of 3x because that is our input. And so altogether, this is going to tell us that g of f of x is equal to the square root of 3x plus 5. Okay, so I want to talk about briefly plugging in numbers the same way that we actually talked about in the last video. So, I think this skill of coming up with the formulas is, I think, a little bit more important because it just shows a level of like algebraic skill, and it's going to become important in calculus, and we'll talk about that a little later in this video. But I do want you to also be able to evaluate these at a specific number. And so let's stick with this function we have here. And let's say that we wanted to evaluate, sorry, so my neighbor upstairs is hammering or jumping up and down or something very loud. Hopefully you can't hear it. So yeah, let's stick with this example. And what I want to do is I want to evaluate f of g and g of f of like a specific number. So actually, I'll not write this again and I'll stick here. And so let's say that now we're trying to evaluate f composed with g of 1. So there's two different ways to do this, just like there are two different ways to evaluate at a number in the last video. So what's the first way we can do it? Well, instead of using, so in the second method we'll actually use the formula that we came up with for f of g of x. But let's say you didn't have a formula for f of g of x. So again, we're still using these same two functions, right? F of x is equal to the square root of 3x and g of x is equal to x plus 5. So one way that you could go about evaluating this is remember the fact that we can rewrite it as f of g of 1. And so now you can figure out what g of 1 is equal to just by using the formula for g of x. So what is the formula for g of x? It says that g of x is equal to x plus 5. So g of 1 is going to be equal to 1 plus 5, which is equal to 6. And so we can rewrite this now as f of 6. So this is really what I meant, by the way, at the beginning of the video when I said the output of one function becomes the input of the other, right? We're finding the output for g of 1, and we're plugging that in. That's becoming the input for f of x. And so how do we evaluate f of 6? Well, now we can just plug it into the function, right? Now we're not dealing with any funny business. We just have plugging in a number. So f of x is equal to the square root of 3 times x. So what would f of 6 be? It would be the square root of 3 times 6. And so that is equal to the square root of 18. And that can be broken down, right? So we can rewrite that as the square root of 9 times the square root of 2. And that can be written as 3 root 2. So that last part of breaking it down, that doesn't have anything to do with function composition, right? That's just simplifying a square root. But yeah, so what is the point of this? So notice that in this method, we never even touched this formula for f composed with g of x. We didn't use that at all. All we did is we kind of took it step by step. We said, okay, if we're trying to find f composed with g of 1, well, we know that we can rewrite it like this. And so what can we do first? Well, we know how to evaluate g of 1, right? G of 1 is equal to 6 just using the formula for g of x. And so once we know that g of 1 is 6, well, we can just plop that number in to our function. And then again, we can just use the formula for f of x. So we never used a formula for f composed with g. We just used the formulas for g of x and f of x. But there's another way to do it, because we did calculate a formula for f composed with g of x, right? We figured out earlier, and actually I'll just write it in the original form. So we figured out earlier that f composed with g of x as a formula can be written as the square root of 3x plus 15, right? That's our formula. And so rather than go through plugging in 1 into 2 different functions, now we can just plug it into this function. We can just use this formula. So that's what I mean when I say this is a formula for a new function. It works just like any other function. If you want to plug 1 into the function, what do? You just replace x with 1. And so we would have the square root of 3 times 1 plus 15. And so that is equal to the square root of 18. And we already saw that that simplifies to 3 times the square root of 2. So we got the same answer both ways, but just like we saw in the last video, basically one way is just using the original 2 functions and kind of taking it a little slower, breaking it down piece by piece. The other way is taking advantage of the work we already did in composing these functions and then plugging directly into that. But the key thing I just want you to understand is that they're equivalent. It's the same. It doesn't matter which method you use. It's really the same idea. And basically by combining the functions to create a new formula, you're kind of like doing the same thing that we did here. You're just sort of doing it in general for x, and that's what then allows you to just go directly and plug into that. Okay, one last thing I want to do in this video is some examples of working backwards. So this is something that is going to be really important in calculus. So in Calculus 1 specifically, one of the main things that you'll be doing in that class is doing a process called taking a derivative. And I'm not going to get into exactly what that means or anything, but basically, in order to take derivatives, sometimes you're presented with a complicated function and you're going to want to be able to break it down into more simple functions. And so function composition is a really powerful way of taking a complicated function and breaking it into these simpler pieces. So what we're going to do is basically for each of the following functions that I'm going to write down, for each of the following functions, and so the functions I'm going to write down, I'm going to call each of them h of x. What we're going to do is we're going to find two functions f of x and g of x such that we can rewrite that function as f composed with g of x. So we're kind of working backwards. Like basically what we're going to do is, instead of me handing you, for example, let's look at this one. So instead of me handing you, here's f of x, here's g of x, compose them together and get this, the way that these problems are going to work is that I'm going to start by giving you this, and you're going to have to tell me, oh, okay, that came from this and this. So we're working backwards. And the nice thing about these working backwards problems is that you can always check your work. You can kind of do guess and check, and I'll show you how that works. Okay, so for the first one, let's do the function h of x is equal to the square root of x squared minus 4. So I should say, by the way, that there are multiple ways of breaking these down. I'm going to do kind of the way that I think is the best way first, just because it kind of, I think it's the simplest way, but I'll show you that I'll show you another way, at least for this one, that it can be broken down. Okay, so what is our goal? Our goal is to find two functions, f of x and g of x, that when we compose them together, we get this function. So basically what you want to be looking at is, you want to try to find an outer and an inner function, because that's really what happens with composition, right? You're taking a function and plugging it into another one. So if you had to describe kind of like what is happening on the outside of this function, like what are we doing on the outermost layer of this function? We're taking the square root, right? That's kind of the outside action that's happening in this function. And then what is the inner function? Like what is the innermost thing that's going on in this function? Well, we're squaring and adding 4, or sorry, and subtracting 4. Can't spell very well today. Sorry, let me just fix that. Right, if you had to kind of just like describe this function in words, that's really what's going on. Is on the inside, you're squaring a number and subtracting 4, and on the outside, you're taking the square root. And so let's translate these into functions. So which one is going to be f of x and which one's going to be g of x? Well, remember that whichever function is on the outside here is going to be your outer function. So that means in this case, f is supposed to be our outer function. So what is a function that takes the square root? Well, square root of x. Right, that's the function that takes the square root of its input. And so what would a good inner function be? Well, if we're supposed to be squaring and subtracting 4, that would be x squared minus 4. And then, as I said, the nice thing is you can check, right? You can double check, like, does this actually work? So if we compose together f composed with g of x, so that would be f of g of x. So that would mean that we're taking f of x squared minus 4. And so what does the function f do? Well, it's supposed to take the square root. And so now we're taking the square root of x squared minus 4. And that worked, right? That is what we were supposed to get. We found two functions that when we compose them together, we got the original function that we were trying to break down. And if you had maybe picked them wrong, like maybe like let's say that you had accidentally picked this one as g of x and this one as f of x, well, then you would, if you checked it, you would figure out, oh, okay, never mind, I got it backwards. So that's why guess and check is a really powerful tool to use in this situation. I want to show you that there is another way to do this, and I think it's a little bit less obvious, but I just want to mention it just in case you thought of it. And I would actually recommend, if you haven't already, pause the video and try to think if you can come up with something else. I think that's a really good exercise to think, can you come up with something else that would work? Two different functions, f of x and g of x, that we could compose. So another thing that would work is we could make our function instead be f of x is equal to the square root of x minus 4, and g of x is equal to x squared. So let's kind of see, like, I think the best, if you were to ask me, how do you know that works, or like, why does that work? The best way to see why it works is to check. Like, that's really the best explanation I have for you. When I say check here, it's not just like, check your work to make sure you got it right. It's really check your work because that's how you'll understand how it works. Okay, so what would this look like? Well, this time our function g of x is just x squared. So we're just doing f of x squared. But also this time, now our outer function f is different, right? So now when we focus in on, okay, here's our outer function, here's what we're plugging into it. Well, this time we just do the square root of, we replace x with x squared, and so we end up with the same exact thing. Now, another way that you could do this that would not be a good answer, that I feel like every quarter someone asks me this, they're like, well, couldn't you just do f of x is equal to the square root of x squared minus 4 and g of x is equal to x? So maybe think about like, why is that not really a good answer? Like, I guess let me ask you two things. First, does that work if you try to compose them together? And if it does work, why is it not really a good answer? So it does work, right? So if you were to try to compose these, basically what would happen is that you would just be plugging in x for x. And so you would get your original function, right? Like here, what happened is you plugged in x squared for x, and so you got x squared minus 4. Or in this example, you plugged in x squared minus 4 for x, and so the x squared minus 4 ended up under the square root. And so this would be the same idea. You would just be plugging in x for x. So it does work, but why is this not like a legitimate answer? Well, it doesn't really tell you anything, right? The whole point of this, and again, I think you'll understand better why this is a thing when you get to calculus, the whole point is to take your function and break it into simpler pieces. And really, by rewriting it the way we did here, you're not making anything simpler. You're just kind of rewriting the same function. So this is technically correct, but not useful. So like on a test, if I asked you this question, you would not get points for that because it's really not telling me anything. Okay, so let's do one more example. So this next one, we're going to do h of x is equal to 1 over x minus 5. So I think this one is a little bit harder because remember my kind of like approach was talking about what is the outer and what is the inner function. And there is some limitation to that because in some functions, there just is like, there really is an outer function, right? Here, it's like literally this is on the outside. Like it makes sense to call that the outer function. This is literally on the inside. It makes sense to call that the inner function. This doesn't really look like that, right? It doesn't really have an outer and an inner function. But if we go back, and again, this is why I think like practice with this is so important and just kind of seeing how it pans out. We did have one that was kind of like this, right? So we had a function where when we composed them, we got 1 over 2x minus 1. And so how did we accomplish that? We accomplished it by having our outer function be 1 over x, and our inner function was the denominator. So basically, we want to say, let the outer function be f of x is equal to 1 over x, and let the inner function be g of x is equal to x minus 5. And so what happens when we put those together? Well, we would get f composed with g of x is equal to f of g of x, which is equal to f of x minus 5. And so then we're just taking our function f of x is equal to 1 over x, and we're plugging in x minus 5 for x. And so we're going to end up with 1 over x minus 5. And so that was it, right? It worked. So there's not always such an obvious outer and inner function, but I think just by kind of playing around with composing different functions together, I think that will give you a good sense of what, how can you interpret outer and inner function when it's not quite as clear as it was in the previous example. All right, so that is it for this video. So in our next video, we're going to be building a little bit more on the ideas from this video and the last one, specifically looking at graphs and how graphs kind of work when you're either combining functions with addition, subtraction, etc., or combining them with composition. So I'll see you all in the next video.